Hi, Algebra. We're going to be working on lesson 20 here, and we're going to be solving inequalities. I'm really going to try to streamline this lesson for you and get down to the nitty gritty and the stuff that you really got to be able to do. So here we go. Notice here that we have skipped to activity 20.3, and in this activity we have Andre and Priya, and they are both solving this inequality right here. Andre is doing it slightly different than Priya. So first thing I want you to do is make sense of each strategy until you can explain what each student has done. Let's look at Andre first. He solved this like an equation and he got down to x equals 3. That's what we did in our previous lesson. To visualize this on the number line, I'm going to put an open circle on x equals 3 because our original inequality was less than. And then he tested to see if x equals 4 is a solution. So he's testing on this side of 3, which is your boundary. And when he does that, he gets 17 is less than 14, which is not true. And so he knows that this side is not where the solutions are. They're going to be on the other side of your boundary, on the other side of 3. And so he ends up getting solutions saying that x has to be less than 3, which is exactly what he wrote here. Do you notice that it's just flipped? 3 is greater than x is the same thing as x is less than 3. Priya solved this problem very differently. She really reasoned through it. She first solved it like an equation and got x equals 3, and again, that's her boundary. Now here's her reasoning. She saw that there was 4x on the left and a negative x on the right. Now if x is negative, meaning something less than 3 on your number line, this side could be positive or negative, but this side, if x is negative, has to be positive, and that's because, let's say for example, x was negative 2. Whenever you add that negative, or excuse me, subtract that negative, it's just going to be like adding. So this side, if x is negative, is always going to be a positive value. And that means that this side is going to be greater than the left side. And that's not what we want, right? We want the left side to be less than the right side. So for this inequality to be true, x has to include negative numbers or x must be less than 3. So she reasoned through it very differently than Andre did, but it still works. On to number 2, we have some inequalities that we're going to solve. The first one is 1/5 p is greater than negative 10. To solve this, I'm going to again think of it like an equation. And then I'm going to get p by itself, which means divide both sides by 1/5. So this is going to end up being 1p equals, and negative 10 divided by 1/5. Remember that dividing is the same thing as multiplying by the reciprocal. So this is like multiplying by 5/1. So we get p is going to be negative 50. This isn't my answer yet because it's an inequality, but I drew a number line. I put negative 50 on it. That's my boundary. I'm going to put an open circle on negative 50. That's because my inequality was just greater than, not greater than or equal to. And now I have to decide on which side of negative 50 are my solutions going to be. So I'm going to test something. I always like to test 0. So 0 is on this side of negative 50. I put that on my number line. Now I'm going to test it. 1/5 p is greater than negative 10. I'm going to plug in 0 for p. And I'm just going to simplify. 1/5 times 0 is 0 is greater than negative 10. And I have to think, is that true? Is 0 actually greater than negative 10? And yes, it is, which means that my solutions are on this side where 0 lied. And that's going to mean that x has to be greater than negative 50. When I solved it, went through all these steps, I got x equals negative 1. Remember, that's my boundary, so I'm going to put that on the number line. I'm going to put a closed circle on this because that is my inequality is less than or equal to. So I want to include negative 1, so I'm going to make it a closed circle. Now I'm going to pick something to test. I'm going to pick 0. That's on that side of negative 1. And so I'm going to plug in 0 to my original inequality. Here I've plugged in 0 for x into my original inequality, and now I'm just simplifying to see if this is true. So on the left, I end up with 28. On the right, I end up with 32. And 28 is less than or equal to 32. So yes, that works. And so that means that this side where 0 is that I just tested, that is where my solutions will be. And so I can write my final answer as x is greater than or equal to -1. And that means that any number from here on this way on in the number line is going to make the inequality true. When I solved this as an equation, I got n equals -4. I put that on my number line as my boundary, and I leave it as an open circle because it's just less than. And now I'm going to test a point. I'm going to test 0 again. You can pick something other besides 0. I just like 0 because it usually makes it easier to solve. But I'm going to plug in 0 for n. And when I do that, I end up getting 0 is less than 36. And yes, that is a true statement. 0 is less than 36. And so my solutions are on this side along with 0. So that means my final answer is x is greater than -4. Starting out solving this one as an equation, I have c divided by 3 on the left-hand side. To make this easier and to get rid of that 3 in the denominator, I'm going to multiply both sides by 3. And when I do that, 3 and 3 end up canceling out. Remember, this is like 3 over 1. And so now I just have c on the left equals, over here I'm going to have -6. That's that 3 times -2. And then times c minus 7. When I finish solving this, I end up getting c equals 6. So that's my boundary. I mark it with an open circle because my inequality is just less than. And this time, as a point to test, I'm going to pick something other than 0. I'm going to pick 12. And I picked 12 because it's divisible by 3. So I'm going to plug in 12 for c into the original inequality. And I'm going to see if it makes it true. Here's where I plugged in 12 for c. And when I simplified that inequality, I got down to 4 is less than -10. And no, that is not true. And so that means that my solutions are not on this side with that point I tested because that made it not true. So that means my solutions are on the other side this way. So anything with x is less than 6 would be a solution to that inequality.